Let's move to the core foundational concepts that form the basis for how to run a safe and successful flight test program. These two foundational concepts are model validation and the build-up approach. Model validation is sometimes referred to as digital engineering or a digital twin. The planned system is modeled in terms of mechanical structure, aerodynamics, electrical, thermal, data systems, and so on. This model of the system is exercised to calculate how the physical system is expected to perform and respond in the planned flight conditions. These calculations are normally generated before the physical prototype is fully manufactured in the course of engineering iterations and design decisions. The model predictions should include uncertainty factors for the calculated responses to account for desired performance margins. Flight test uses the modeled performance of the system to target test resources to the critical conditions as well as to identify safety considerations. These test results are used to either confirm the accuracy of the model or, alternatively, to retune the model to match test results. By spot checking critical points in the model, both at inflection points and the edges of the envelope, the development process can be confidently and safely accelerated towards operational fielding. Model validation is often described by flight testers using the mantra predict, test, validate. The model predicts system performance, test evaluates the predictions, and the resulting flight test data is used to validate and refine the model. When choosing conditions for flight tests to address model validation, it's important to prioritize and sequence test points using the build-up approach. The term build-up approach is a simple way to express that initial flight test conditions can be identified with lower risk and higher confidence in the model in order to progressively work out to the edge of the envelope. This is not a one-dimensional approach, but requires a collaborative and multidisciplinary team to consider how to intelligently move into areas of lower model confidence, higher safety risk, higher energy states, lower terrain clearance, or reduced engineering margin. The build-up approach sequences prerequisite tests that contribute certainty through model validation. By starting with test conditions that have lower model uncertainty and lower risk, the refined model predictions can be fed back into subsequent tests to increase safety and efficiency. So we'll start with low model uncertainty and low risk, with the number 1 there, and then move up through tests in increasing order of model uncertainty and increasing risk. But those tests are made possible by feeding back in data from the initial lower risk and lower uncertainty